Hey everyone, and welcome to today's Explainer. We've got a seriously cool, fast-paced journey mapped out for you today. We're going to trace the totally fascinating path of the materials we literally wear every single day. We're talking about going from a tiny little seed planted in the dirt all the way to those high-end sustainable garments hanging in your closet right now. But before we even dive in, I've got a quick question to throw your way. What do the wooden table you might be sitting at right now, the paper notepad on your desk, and your absolutely favorite coziest cotton shirt have in common? I know, it sounds like a trick question, right? They look completely different, they feel different, and we use them for entirely different things. But here's the crazy part. At a microscopic level, they share the exact same biological foundation. The secret ingredient linking all that stuff together? It's cellulose. You can basically think of cellulose as the muscle fiber of the plant world. It forms the biological skeleton for pretty much every plant on Earth. And for textiles, well, we take these microscopic plant muscles, extract them, twist them together, and boom, you've got yarn. So your table, your notebook, and your favorite shirt, they're really just different expressions of the exact same amazing botanical structure. So just to set our academic baseline here for the explainer, what exactly is it? By definition, cellulose is the incredibly tough, fibrous material found in the cell walls of all plants. It provides the absolutely crucial structural support that lets plants fight gravity and actually stand upright. I mean, without it, trees literally couldn't grow tall, and a cotton plant would just completely collapse under its own weight. Okay, here's our roadmap for today. 1. Nature's muscle fiber. 2. The great divide between natural and regenerated. 3. From wood to wardrobe. 4. Solving for human comfort. And 5. The circular textile future. Let's get into it. Section 1. Nature's muscle fiber. When you really zoom in, the sheer complexity of these natural building blocks is just mind-blowing. The way these fibers are so intricately bundled together inside a plant stem, it's like a microscopic architectural masterpiece. And it's not just neat biology to look at. This is the highly breathable, entirely natural, and super sustainable foundation of the entire global textile industry. It's the literal starting point for every single thing we're going to talk about today. Moving right along to Section 2, the great divide, natural versus regenerated. So how do we actually categorize all these fibers? Well, the crucial dividing line all comes down to the level of human intervention required to process them. On one side, we have Category A, the natural cellulose fibers. Think of these as the direct group. We're talking fibers like cotton, jute, and linen that are harvested straight from the plant. Contrast that with Category B, the regenerated cellulose fibers. This is the man-made group, which includes stuff sourced from wood pulp like eucalyptus, bamboo, or pine. And those, they require a ton of heavy processing to actually become fabric. The contrast here is honestly pretty wild. With natural cellulose, you're talking about straight-up farm-based extraction. You harvest it directly from the seed, the stem, or the leaf, then clean it and spin it. No heavy chemical melting, no lab coats. Regenerated cellulose, on the other hand, is heavily lab-based. You literally take hard plant matter, dissolve it into a liquid soup using an intensive chemical process, and then mechanically reconstruct it back into solid threads. It is a wildly different approach to harnessing the exact same fundamental plant material. Which brings us to Section 3, from wood to wardrobe. For those natural fibers, extracting them relies entirely on direct physical harvesting. And there are basically 3 distinct pathways depending on where the fiber actually lives in the plant. You've got seed fibers, like cotton, coming from that nice, fluffy boll. You've got bast fibers from the stem, like jute and linen. And then leaf fibers, like sisal and pineapple, which actually require a lot of mechanical scraping. But regardless of the source, the end game is always the same. Isolate that fiber and get it to the spinning wheel. Let's just zoom in on bast fibers for a second, stuff like jute and linen. The process here is actually ancient and totally fascinating. You start with the plant stem. Then comes step 2, the retting process. And retting literally just means soaking the stems in water until the outer skin rots right off. You essentially have to rot the plant away to isolate those super long, strong inner muscle fibers. Once that's done, you extract them, and finally, you're ready for clean spinning. Now, flip over to the regenerated side, and honestly, the process feels like pure modern alchemy. We are taking solid wood, like a piece of eucalyptus or bamboo, transforming it into a thick liquid just so we can turn it back into solid threads again. It is a jaw-dropping feat of industrial engineering. This is how we get materials like viscose, which is famous for being incredibly silky, or lyocell, the total eco-champion that recycles 99% of its processing chemicals. Let's run through the rapid-fire sequence of that alchemy. Step 1, we start with raw material, completely ground down into wood pulp. Step 2 is dissolution. We dissolve that pulp into a really thick chemical soup. Step 3 is where the magic happens, extrusion. We push that liquid soup through these microscopic holes called spinnerets. Just imagine pushing it through a tiny, tiny shower head. And finally, step 4, formation. The second the liquid exits those holes, it instantly solidifies into these continuous, unbelievably smooth threads. All right, section 4, solving for human comfort. It is genuinely incredible how well this plant biology translates to what we actually want to wear. Because it's plant matter, cellulose absolutely loves water. It acts like a sponge for sweat, making it super breathable and highly absorbent. It's heat conductive too, meaning it actively pulls your body heat away to keep you cool. It's super dye-friendly, drinking in those rich colors thanks to that absorbency. And my absolute favorite trait, no static shocks. It creates a totally static-free zone, unlike something like synthetic polyester. It's like it naturally evolved just to keep us comfortable. Because of all these traits, every fiber develops its own sort of industry personality. Let's walk through this matrix really quickly. Cotton, that's the all-rounder. Super reliable, easy to wash, universally familiar. Jute is the golden fiber, incredibly strong, eco-friendly, and lately moving from rugs straight into high-fashion blends. Linen is the luxury choice, perfectly cool for the summer, even if you do have to deal with some wrinkles. Over in the regenerated camp, viscose is known as the silk mimic, giving you that beautiful drape without the real silk price tag. And bamboo is the softness champion, boasting an incredibly soft touch and even some natural antimicrobial properties. So practically speaking, how do you tell them apart without checking a label? You do the hand feel test. This is an absolutely essential skill in textiles. Natural cellulose, like your typical cotton or linen shirts, generally feels crisp or dry to the touch. You can literally feel the natural texture. But regenerated cellulose, because it's extruded through those tiny little shower heads we talked about, it typically feels very cool, slick, or buttery to the touch. Seriously, next time you're shopping, just close your eyes and feel the fabric. You'll be blown away by what your hands can figure out. Okay, time for a quick pop quiz to see if we're putting all this together. Question 1, why is a 100% cotton shirt way better in the summer heat than polyester? Remember the sponge effect? Exactly, superior breathability and absorbency. Question 2, what's the budget-friendly silky option? Yep, that's our silk mimic, viscose. And question 3, which cellulose fiber is Bangladesh super famous for and how is it evolving today? Jute. It used to just be for rugs and sacks, but now this golden fiber is being softened up for high-end fashion blends. You guys are totally nailing this. Finally, section 5, the circular textile future. The biggest takeaway here is that the future of textiles is moving way, way past cheap, fast fashion. The industry's entire future absolutely relies on high-value, highly sustainable cellulose applications. We are pushing hard toward a global circular economy, and these plant muscles are perfectly positioned to meet those incredibly strict environmental demands. Why? Because they are derived right from nature and they can responsibly return right back to nature. Let's look at what that actually means on the ground. First up, sustainable fashion. There's a massive breakthrough right now called Refibra. It brilliantly takes recycled cotton scraps straight off the cutting room floor and merges them with fresh wood pulp to spin new thread. It perfectly closes that sustainability loop. Number 2, home textiles. We're seeing a massive pivot to premium hemp and linen blends for high-end export quality bedding. And number 3, medical textiles. The industry is heavily leveraging the fact that cellulose is biodegradable and non-toxic to create superior, entirely eco-friendly surgical bandages and wipes. It's a pretty wild ride from a stalk in a field to a life-saving bandage or a high-end dress, right? Which leaves you with one final thought to throw your way. Thinking about everything we've uncovered today, what plant muscles are you going to find when you check your clothing labels tomorrow morning? Are you going to feel the crisp, dry snap of natural cotton or the buttery, slick drape of regenerated bamboo? I definitely encourage you to go dig through your closets and literally feel this farm-to-fabric journey right in your own home. Thanks so much for hanging out and learning with me today, and I'll see you in the next explainer.